Good morning, students. Myself Rohit Ahuja, and today I've got something for you from class 10 syllabus, chapter 1, chemical reactions and equations. I think the time has come when we should start working for ourselves and using this time really judiciously and wisely. So let's all start with what we have got for you today, right? So our first chapter is chemical reactions and equations. First of all, we'll understand something from class 9 syllabus, a recall from the class 9. What are physical changes and what are chemical changes? A physical change is one in which no new substance is formed. For example, melting of ice, dissolution of sugar or salt in water. So when ice melts, ice changes to water, but no new chemical substance is formed. The composition remains same. Similarly, dissolution of water or sugar or salt in water makes the formation of a mixture. A mixture is formed, a compound is not formed. So again, it's a physical change. Now, chemical changes. New substances are formed with entirely new properties. For example, burning of paper. So when paper is burned, paper reacts with oxygen, combines with it to form smoke and ash, which are entirely new substances. The other example, burning of candle. So when candle is burned, it's both a physical and a chemical change. You can see here. So when the candle is burned, melting of wax takes place and then evaporation of wax to wax vapor. These both are physical changes. And burning of wick of candle and burning of wax vapors then is a chemical change. Some more examples involving chemical change. Rusting of iron, sparklers which produce dazzling lights on burning, photosynthesis, digestion of food, milk to curd, conversion. Foul smell by potato chips when they kept for a longer period of time. All these are chemical changes. Fermentation of grapes are here's the change we observe on bleaching or coloring. Burning of fuels in our car, baking of cake in oven. All these are chemical changes. In all these examples, is one thing is very common. The nature and identity of original substance has somewhat changed. See, the nature and identity. Something new has been formed, and chemical composition has changed, appearance has changed, color has changed. Definition of a chemical reaction. A process in which one or more substances are converted into different substances having different properties. We call it a chemical reaction. So during a chemical reaction, only rearrangement of atoms takes place. Remember, rearrangement of atoms, but no new atoms are formed. Because it obeys law of conservation of mass, we have learned in class 9th, which means that mass of reactant is always equal to mass of products. So number of atoms on left hand side and right hand side of an equation should be the same, and for this we have to balance a chemical equation, right? So in an equation we have left hand side and right hand side. Reactants reacting to form products. The arrow is pointing towards right side, towards products. This is a rule. For example, we consider this word equation. Magnesium plus oxygen gives magnesium oxide. Magnesium oxygen are reactants. Magnesium oxide is a product. So we'll convert this word equation into a chemical equation. Mg plus O2 gives MgO, 2Mg, 2MgO. These two are the variables, and this is a balanced chemical equation. And now we are in a position to define this chemical equation. A schematic representation of a chemical reaction with the help of symbols and formula of various species is called a chemical equation. So when writing a chemical reaction, we don't balance it, but we call it a chemical equation only after we have balanced it. It is always balanced, but why? Why do we need to balance? It is balanced to observe law of conservation of mass, as no new mass can be created and no mass can be destroyed. So we have some small home tasks for you also. Review all acidic and basic radicals from class 9th, chapter 3, atoms and molecules. First of all, you should also be knowing what are acidic and basic radicals. Acidic radicals which contain an ion from the acid, and the basic radicals which contain an ion from the base. Example, acid and base you all know give rise to salt and water. So HCl and NaOH combine to form NaCl and water. You can see here salt is NaCl, sodium chloride, the common salt. It contains sodium ion coming out from a base. So it is a basic radical. Cl negative ion has Cl negative, this Cl negative ion is coming from the acid. So it is an acidic radical. The other basic radicals, sodium ion, lithium ion, hydrogen ion, magnesium ion, calcium ion, etc. And the acidic radicals, chloride, bromide, hydroxide, bicarbonate, sulfate, carbonate, etc. So now your home task, again, revise all these radicals in order to translate word equation to a chemical equation, which we'll be practicing in our next class, next work. Thank you so much.